Okay, very nice. That's very fortunate. All right, so my name is Andrej, and I'm from the company SCIPRIOS. So probably a few of you have already heard about us, but I would also expect that many of you still haven't heard about us. So in the beginning, I would thus like to give a short introduction to the company. So we're located in Nuremberg, Germany, and essentially we are a spin-off from the University Erlangen-Nuremberg and the Helmholtz Institute, which are located here. And we have two main pillars for now. So lab automation equipment, the Spincoating robot, which I will tell you about in more detail today. And of course, also the pilot production equipment. And most importantly, typically we have the correct processes available for customers so that they can get started really quickly. And here are two main research topics, or topics here are organic solar cells and perovskite solar cells. That's the topics where most of us did our PhDs. But more broadly, we can also serve like printed electronics, like anything where you need spin coating or like doctor blading, for example, in fuel cell coating or preparing samples for biology. But let me please give you a very quick visual introduction to the like pilot production equipment and lab equipment, so that everybody is on the same page and can imagine what I'm talking about. So talking of the pilot production equipment, for example, with here what was around 20-meter long line. I will get into a little bit more detail on the next slide, where you can produce solar modules in a single pass. So you have 4 coating stations, you have 3 laser structuring stations. So essentially you can really produce a full organic or perovskite solar module here. And then there's the lab equipment, to which we will get in more detail later on. And this is essentially a workhorse, the so-called SpinBot, the spin coating roboter. Before we get to more details about that one, I would just highlight that the pilot production is something that pilot production equipment that we develop, design, and sell. But our partner in Denmark is the manufacturer. So our partner has decades of experience in roll-to-roll production machines, and also a large range of coating techniques. And we have the more in-depth expertise in the device technology and laser structuring, for example. So an example, as I've given you here, is such a single pass roll-to-roll line. And here the technologies which are important are, of course, the slot die coating, but also gravure, flexo, screen printing, and of course laser patterning techniques. These are very important here. But of course, not everybody would like to start with a 20-meter line, but you might want to have a very compact, small system to first start transferring your manual doctor blading results to really flexible substrates on a roll-to-roll machine with slot die coating. And here we can, for example, we provide the 150 R2R, which you can even fit inside a glove box if you would like to, in nitrogen or argon atmosphere. Then, of course, which is very important for us and which we also provide, are the laser patterning systems. And as you might see, I don't know if you see my mouse, I hope so. So this is a colleague from us from the solar factory, and he is showing the organic photovoltaic module, record module here. I think he already holds this position for 2 years now. And he used the laser patterning system exactly as the one which we use and provide. And if you're interested, you can always ask for details or ask for customization. But at the heart, there's a green laser, nanosecond laser, which is definitely more industrially compatible than the femtosecond lasers, which we started at in research, but now we've stepped up our game. And typically we provide a working area of some 30 times 30 centimeters. And if you would like, specifically for flexible substrates, we can also like mount a camera detection system to really get the best patterning results. Okay, but let's stop with the introduction here and let's get to. Now I have an additional slide. I'm sorry. Here on the left, you see a sheet-to-sheet system, and of course, in an R&D project, we wanted to develop a real roll-to-roll laser patterning, because beforehand we had some stop-and-go roll-to-roll laser patterning, but here, as I hope you can see the video, it's just a short video, a very preliminary one from long ago. We were just laser the P2 line on a module here. And thanks to precise web alignment, and we can achieve very good results here, even without a camera system. But now let's really switch gears and stop talking about the pilot production equipment, but let's really get to a bold statement here. Namely, the era of manual spin coating is over. I mean, maybe not for a few years, but the idea is clear. And I would just highlight this by showing you a video here from our SpinBot. Essentially, it starts with picking up a substrate, placing it into a spin coater, and picking up a tip, picking up solvent. Essentially everything which you can do manually, but here it's faster and the robot doesn't get tired. So the piping module detects the liquid by itself. Because we've implemented a high-level piping module, and then you can deposit your aspirated liquid onto the spin coater and start the spin coating process. And ultimately, after you finish the spin coating, you place the substrate on the hot plate. And let us zoom in a little more here. So you can grip the substrates very conveniently, easily, place it quickly into a spin coater. Again, pick up the tip, and once again, detect the liquid and aspirate the solvent on which is located here in a heater shaker, continuously shaking, and you can also adjust the temperature, of course. All right, one final step here. Dispensing of liquid, and ultimately the spin coating starts again. Then, of course, you need a simple user interface. I will get to this one on the next slides, where you can conveniently adjust the number of substrates, which parameters you want to fine-tune. And by now, the spin coating is finished. You pick up the sample again. Everything as a user, you don't have to do really a lot. You just start your process and everything is set up already after installation. And ultimately, you will finish with the annealing. Okay, so hopefully everybody of you could see the video and at least partly can agree with me that we should step up our game and automate the lab processes, which are sometimes tiresome, exhausting, and were one of the most important keys takeaways for me is about that reproducibility sometimes in the lab. It's not so good as you would expect if you have 10 PhDs doing the same materials. Sometimes you get completely different results, unfortunately. But this is now fixed with the SpinBot. So one main takeaway from the SpinBot, other than many would maybe expect, from keywords like high throughput, the most important first start point is reproducibility to me. Then you gain the control of every experimental parameter, every detail. We'll get to that on the next slide. And of course, you can share, save your recipes and share with your partners, your group. And ultimately, when you have well thought out experiments, then you can really drastically increase your throughput. All right, so how does such a user interface look? Because of course you will have many parameters, of course, and it's in some sense it's unavoidable that you end up with a wall of parameters. So on the left side here, I hope you can see my mouse, are the parameter settings for our basic spin coating procedures. So you can choose everything from the spin coating parameters, like which spin coater you want to use, the spin coating times, the spin velocities, and spin accelerations. And here, of course, it's very crowded. You could select each parameter for each individual substrate. But of course, you can also just press this use simple settings button, and then everything will disappear except for the parameters which we really would like to tune. And in that case, it's only the spin coating velocity, for example, and you don't want to change anything else. Of course, you can save load any of these parameters in an XML file format. You can manipulate the XML files in external software, so catchphrase machine learning, and feed them back into the software if you would like to. So on time, it's fine. Speaking of perovskites, because this is obviously a little bit more advanced than organic solar cells and more advanced to automate, then you will get a lot more parameters because you also want to have quenching steps. So the upper part is mostly basic spin coating, and in the lower part we have three variants of quenching procedures, something like pipette quenching, and gas quenching is an important procedure, but also syringe quenching. And here again, you can, like, in that case, you can choose like a second spin velocity because it was important for some customers. You can choose the solution volume for quenching and this dispense rate. And before you get lost in the wall of parameters, let me just quickly, again, it's a very visual presentation based a lot on videos. This was the basic spin coating step essentially. So the initial solvent is deposited, and then I chose a very long time for quenching here for the syringe quenching. So now you wait, and ultimately, now it starts. You have the quenching process starting. You could do the same with gas quenching. And here I won't show you a video because you will not see a lot. But I will just show you a result from a colleague from the Helmholtz Institute. So this wasn't measured by us, but with the same system essentially. And here you see the results of gas quenching with perovskites. So we could like optimize maybe a little with the areal distribution, but you can see very nicely that you can tune the duration of nitrogen quenching, and then you get a very nice perovskite black, very nice perovskite layers here. So what is the message here? So we have already several procedures prepared, like basic spin coating, several quenching spin coating procedures, which you can control really to a very precise detail. And of course, sometimes there will be procedures which we didn't map, but there we have an efficient framework to really quickly develop new procedures and program them into the software. But of course, catchphrase high throughput. Maybe I can tell you, like from comparison, the robot is a lot quicker than a human being, but maybe it's not enough for you and you want to really up your game and want to have high throughput. Of course, you can use such a robotic system very efficiently to use several spin coaters in parallel, which I, as a human being, wouldn't like to do. This is from our first development platform, so it's even the old spin coaters, and we didn't pursue it too much for now because annealing is mostly the bottleneck. So there's no good point most of the time to use a lot of spin coaters in parallel. But of course, with an advanced piping module, you just aspirate 4 times the volume. I think it was like 200 microliters here, and deposit 50 microliters each on each substrate. And number 2 is in operation, and so on. Let's see. Essentially, we don't have to look at the picking out process again. Then all substrates will be deposited on the hot plate, and it continues. But let's switch to other processes, because we mostly talked now about the spin coating robot, but of course, speaking of scaling up, spin coating is not always the procedure which you can go for, but you would like to go for blade coating, for example, or even slot die coating. And here, this is also a fairly old video where the coating has already happened. And one issue is, for example, that you have the residual solvent here, which you would like to get rid of, but you can very conveniently use the piping module again, get rid of the excess solvent, and then you keep your workplace clean, because with a robotic system, you don't want to let the robot do some cleaning or any similar feats. So this is not really desirable, but this is in this automated blade coat prototype, we can easily suck back, aspirate the residual solvent. And I can later on show more details, or we will make some new videos later. But here you can really dock the blade with a high precision. You can adjust the gap, the speed, the temperature, and then simply after one coating step, exchange the consumables here, the blade, which you can also customize if you would like to. But let's get to the next slide. So what else? If you want to ultimately have the materials acceleration platform, as in the title, you want to have several different things, and maybe some custom aspects here, and some customers want to have like custom substrates which might not be square as all the other ones which I've shown before. And here we have like a solution, a quick solution for having rectangular substrates. And just a quick video, spin coating at 10,000 RPM and taking it back again. So everything works exactly as is, with some additional hot plate adapters later on. And in principle, it works all fine. So there we are also available to adjust to your needs if you want to. And customize, speaking of like customization and even like interfaces, and we've written the software in LabVIEW, and at least our robotic system is all like written in LabVIEW, and the devices there can communicate easily. But a customer of us wanted the characterization box here, but they wanted to implement the optical fibers, the spectrometers all by themselves, and then ultimately have a Python program, and then also run the stage also with a Python program. And here we can provide, like, we are open to providing any communication interface here to like send commands to the robot, for example, to pick up a sample and take it back again and put in a new one. Let me just show you. So the left part is being run by a Python program, which just sends command to our LabVIEW based system. And it has finished a substrate, so the robot will take it and place the next one. And after the robot has gone to the correct position, like just to be out of the placement position, we can now have the Python program can continue and do its thing. So they're speaking of communication, we are providing, in that case, for example, a TCP/IP interface, a very simple one. And the idea is obviously not to only produce solar cells, but to analyze them and to characterize, analyze, and measure them. And of course, some people would like just to add one or two characterization units, or you can even think of having multiple spin bots, robot platforms, one for production of materials and one for characterization. So we have the characterization box of our own here, which can do like absorption, PL, EL, and if you have full devices, the IV characterization, IV curves. Then we are also in the process of integrating for perovskites, very important, the PL and EL quantum yield device here, the Luki Pro from the Berlin startup, but also currently we are doing the XRD from Igaku. We are looking at the Brooker device for EQE and FTPS, and if you are into that, also IR spectroscopy. And lately, from our neighbor company here in Nuremberg, the maximum power point tracker device. So we're actively establishing a foundation to have interfaces in the software to be able to connect to third-party devices and trigger measurements, for example. And all this together, like spin coating, blade coating, customization, will us in the end lead to the materials acceleration platform, which for now is a concept study, where you can really connect, like going bottom, let's call it bottom up, like having a functional spin coating robot, which can work on its own, but which you can really implement into a robotic platform where you can accelerate production manifold, or let's call it 2- or 3-fold, by having, for example, 3 production robots, which do layer 1, layer 2, layer 3, with intermediate robots, which can transport system, the carriers, for example, and then characterization robots. And of course, if you need this, you can also have an evaporator. And then in parallel, of course, so there's really a system which can quickly produce full devices. And what you would ultimately then, of course, like is some external software which has machine learning, database, and we're actively developing the interfaces now. All right, so I think my time is already up. And with this, I would like to thank you for your attention. And yeah, I'm glad to answer any questions.